All right, good evening, everybody. So today what we're going to do is we're going to talk about mole conversions. For most of you, this should be really a review of stuff that we did in Chem 1. Okay, so your essential question for today: how is the mole used in chemistry? Okay. And a lot of you already know what a mole is, okay? A mole represents the number of representative particles So that means the smallest piece of matter that is still that substance. So a representative particle for an element would be an atom. A representative particle for a compound would be a molecule. Okay, so it's the number of atoms or molecules in the molar mass of a substance. Okay, so a mole is equal to 6.02 times 10 to the 23rd power particles. That's how many are in that molar mass. Okay, no matter what substance it is, if I have a mole, I have that many particles. And that number, of course, is Avogadro's number. Okay. And that's why Mole Day is October 23rd. Get it? Okay. So how is molar mass calculated? Well, that's easy. It's from the periodic table. Okay, if you look up those masses on the periodic table, that is the atomic mass for that element, its average atomic mass in atomic mass units, AMU, but it's also the mass of 6.02 times 10 to the 23rd atoms of that substance, okay, in grams. So just know that that number is really, it's doing two things. It's telling you the mass of the atom in atomic mass units, and it's also telling you that if I have Avogadro's number of particles, it's going to have that mass in grams, okay? So the sum of the masses of all of the elements in a compound gives you the molar mass of that compound. So for example, if I needed the molar mass of sodium chloride, I would look up sodium, which is 22.99, and I would look up chlorine, which is 35.45. Make sure you're using the AP periodic table, okay? And if I add those two things up, you end up with, and I'm going to kind of put it over here, 58.44 grams per mole. Okay, also written 58.44 grams times moles to the negative first power. Okay, so just be aware that sometimes molar mass is written like that. There, I'll move the paper up. Okay. All right, so how are conversions performed? How can I turn grams into moles or moles into particles? Well, we already know the math that we do behind that. Okay, so that's going to be dimensional analysis. Everybody's favorite, okay? And we already know the steps to dimensional analysis. Whatever value you are given, start with that. Okay. And then you set up those conversion factors. Like 1 mole equals 58.44 grams, okay? That could be a conversion factor. Or 1 mole equals 6.02 times 10 to the 23rd particles. That would be another conversion factor. You set those up so that the units cancel each other out. When I have the same unit on the top and bottom of a proportion, they cancel out. Just like if I have the same number, top and bottom of a proportion, they cancel out. Okay? All right, so our first example here. How many atoms are present in 18 grams of carbon? Okay, so here's my given right here, 18 grams of carbon, so I'm going to start with that. Okay, now if we're doing this so that units cancel out, I know that something about grams of carbon has to go down here. And what is that going to be? It's going to be the molar mass, because that's the only other information in grams we've got, and it's going to come from the periodic table. So on your periodic table, it says that carbon has a molar mass of 12.01. That's the mass of 1 mole of carbon. Now, I was not asked for moles. I was asked for atoms, so I need to drop this down so that the unit cancels out. And what I know is that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So you may be thinking to yourself, this looks super hard. How am I supposed to do this without a calculator? Well, remember we talked about simplifying steps. So if I look here, I've got 18 on top and 12 on the bottom. 18 on top and 12 on the bottom. 18 on top and 12 on the bottom, that's about 1.5 right there, okay? So really, I've got 1.5 multiplied by Avogadro's number. So 1.5 times Avogadro's number, half of Avogadro's number is going to be 3.01. So if I add that all up, I get 9.03 times 10 to the 23rd atoms. Okay, so one more time on that, I simplified. 18 over 12 is about 1.5. 1 of Avogadro's number is 6.02. The half would be 3.01. So 1.5 would be 6 plus 3, and that's 9. Okay, so there it is. Okay, so how are particles counted in a solution? Well, first off, what is a solution? Remember that you have two things in a solution, okay? You have the particles that are dissolved in there, that is the solute. Okay, and the liquid that they are dissolved in is the solvent. Okay, so remember that it's a mixture. Molarity is the measurement of those particles dissolved in the solution. In fact, the formula for molarity, capital M, is going to be moles of solute, because that represents particles, right, over liters of solution. Now, this is very important. It has to be moles and it has to be liters, okay? And we talked about it last year. You can have your little molarity triangle, moles on top, molarity, and liters on the bottom, okay? So we can use this to solve problems here. Calculate the concentration of a 500 milliliter, remember I said it had to be liters, so we're going to have to fix that. Calculate the concentration of a 500 milliliter solution containing 29.2 grams of sodium chloride. Again, we're going to do this without a calculator. All right, well, what do I need? I need moles and I need liters in order to get molarity. The liters part is easy. If I have 500 milliliters, all I have to do is take that decimal and move it back 3 spaces, and that's going to be 0.500 liters. So that part was super easy. It's just moving a decimal. Now, we have to turn grams into moles, which again isn't that difficult. Start with what you're given. Grams goes on the bottom so that units cancel out. It's sodium chloride, so that was 58.44 is 1 mole. If I look at it, I have 29.2 over 58.4. If I think about that real hard for a second, that looks like about 0.5. 29 over 58 should be about 1 over 2, so that simplifies to a half, 0.5 moles. So I have 0.5 moles of sodium chloride, and I need to divide that by liters. If I want molarity, I cover that up. Moles over liters gives me molarity. So moles divided by liters. Again, things cancel out, right? It's a 1 molar solution. So there it is. Okay. Now, something we do have to be aware of is ionic compounds. Okay, so when ionic compounds dissolve, aka dissociate, okay, they break up into their respective ions. So water is a polar molecule, which we're going to talk more about throughout the year, but it has the ability to pull the positive away from the negative, and that's how ionic compounds dissolve. They dissociate, they break apart. Okay, so for example, if I had this aluminum sulfate right here, when that dissolves or dissociates, I am going to have 2 aluminum ions, and I'm going to end up with 3 sulfate ions. So for every one of these that dissolves, I'm going to end up with 2 of these floating around and 3 of these floating around. Okay? So for example, let's say I had a concentration of a solution, and I know that the molarity of the aluminum sulfate is 1 molar. But I want to know the concentrations of aluminum and sulfate individually. Okay, so overall the compound has a 1 molar solution, but I want to know the molarities of each ion. It's actually a really simple problem. I have 1 molar, and it's 1.0, so let me put the 0.0. Okay, I have 1 molar Al2 SO4 3. So what I'm going to do is, I'm going to go ahead and say that for every 1 aluminum sulfate, I get 2 aluminum ions. And so this is math I can do. It's really easy. 1 times 2 is 2. So it's 2 molar aluminum. And I do the same thing for sulfate. I'll go ahead and set it up, but really I think some of you guys are probably doing this in your head already. So for every 1 Al2 SO4 3, I end up with 3 sulfate ions, and so the molarity of this is going to be 3.0 molar. Okay, so you just have to make that small adjustment if you're looking at the concentration of an ion as opposed to the overall concentration of the solution. Okay? All right. So then we come to dilution. Okay, so dilution just means basically watering it down. And in science words, we are adding solvent to the solution, which decreases. I'm going to put decreasing so that my stuff agrees there, English-wise. So adding solvent to a solution, decreasing the molarity. That's the definition of dilution. Okay, and we have this very familiar formula. Okay, your initial molarity and your initial volume multiplied by each other is equal to the ending molarity and ending volume multiplied by each other. Okay, so really these are just plug and chug problems. So if this is my example right here, let's say that I have that 500 milliliter solution. It's got a concentration of 1 molar. This is my V1 and this is my M1. Okay, now we dilute it and it ends up having a final volume, so this is going to be V2 of 2 liters. Okay, all I do is plug that into this equation. So I have 1.0 molar times, we have to change that again, 0.500 liters equals, we don't know the ending molarity, but we do know the ending volume is going to be 2.0. Okay, so remember your order of operations. The first thing we're going to do is multiply. So 1 times 0.5 is super easy math. That's 0.5. Okay, is equal to the variable M2 times 2.0. So what we're going to do is divide both sides by 2. 0.5 divided in half is going to be 0.25. So that's going to be the ending molarity. Okay. So for this one, I do want you guys to write a summary, and this is going to be part of your grade for tomorrow. So I just want you guys to kind of go over what things are on each page down at the bottom. Just make a summary of what things are there so that you can find it really easily in your notes later. So just like a very short list down here that tells you what's on each page, just so you can reference it later. You guys have a good night.